Hello everyone, welcome back to Elmer Time. It'll be Elmer Time number 15. Today we will dive into the phonetic alphabet and a little bit on reading schematic symbols and the parts therein. So stay tuned. This is Jeffrey, AD7LN. Welcome back to the radio room. Hello everyone and welcome to Elmer Time number 15. Glad to see you're back. And today we're going to talk a little bit about schematic symbols and phonetic alphabet. As far as schematics, if you're new to the radio hobby, or if you have no information at all on basic electronics, what if you did have some information, some knowledge on basic electronics? What if you could go online and look at all the schematics that are available for free to build a very basic product? Being that you would be a radio operator, what if you could build a very small beat frequency oscillator, a standalone type, that you could sit next to a shortwave receiver that doesn't have sideband capabilities? But being that you've got a BFO, now you've got sideband for that shortwave radio. What if you wanted to build a small audio amplifier for one of your radios so that your audio signal can travel along a longer length of wire? Say if you wanted to wire in a speaker on the other end of the house, an audio amplifier would come in handy for that. Maybe an audio manipulator, maybe something that'll take away the high-end hiss. You know, there's tons of things that you can build. Different kinds of meters. You name it. Anyway, if you had some basics, you'd have a stepping stool to get on your way. So let's see if this will help you a little bit. And then we'll get into the phonetic alphabet. So let's get into it. Okay, we got a lot of ground to cover. If I'm going too fast, just replay the video. So as far as schematic symbols, if you were to look at a electronic schematic, even the simple ones, you're going to see the same thing no matter if it's a super high-tech thing or just a simple 5 or 6 component device. But anyway, let's start with a resistor. Schematic would look like that for a standard resistor if you were to look in a schematic. Of course, what a resistor is, it's to reduce current flow, adjust levels and signals, and is also a voltage divider. Now, there's different kinds of resistors, many different kinds. There are variable resistors. If you were to tune a radio, such as your volume knob, that's probably a variable resistor. The tuning goes across. There's so many of them. I'm only going to cover so many of them. You'll have to excuse my poor writing skills here. But anyway, if it has a line through it like that, that would be a rheostat. It has a circle around it. It has arrows to it. can't make the arrows very well. That would be a photoresistor, which it changes its value depending on how much light is hitting the photoresistor. There is a resistor that changes its value according to temperature. That would be a thermistor. And the it's going to have a T in it. Sometimes a degree sign as well. That would be a thermistor. There's a real strange one that doesn't come up very often in the hobby style kits or what have you. This would be a varistor, and that's basically used for high voltage surging, so you probably won't see that too often if you're just starting out. Or another variable of the varistor would be just a circle like that with a V in it. Same thing, varistor. Now resistors are usually rated in, or they are rated in watts. And if you remember our last video dealing with watts and resistance, resistors are rated in watts from 1/8 watt up to, what is it? I think it's 1 watt. There are bigger resistors than 1 watt, but once you go over 1 watt, they are considered a power resistor. Once they go up above 1 watt. And they're mainly for dissipating power. But pretty much all resistors, when they limit the current flow, the product is that it generates heat. So resistors have to be rated appropriately for the circuit. If they're the incorrect wattage for the application and it's rated too low, that resistor can burn out. So yeah, we were talking about this last time. And this comes into play again for resistors, obviously. So, moving on, next one would be a capacitor. A capacitor basically stores and releases an electric charge in a circuit. There's many different types. There's ceramic or film types of capacitors. You've probably seen them. They're round, or their film ones are square. They're non-polarized, which means they can be set in a circuit, either reverse or forward, and it won't matter. They usually have 3 digits, 3 numbers, indicating how to read the value of the capacitor. And in a schematic, a non-polarized would be like that. A polarized would be like that. And this side would be the anode. This is the cathode. This is the negative side. This would be an electrolytic style capacitor, or polarized. These here you normally see as a round, small can with two leads coming off. And there's many different types of variations. There's a variable capacitor, like a tuning wheel. There's a trimmer cap, which is a fixed variable, which means it's variable, but they've tuned it in the factory. Say if it was in a radio, those small capacitors that are on the board, they've tuned it to where it needs to be and maybe put some wax on top of it so that nobody can go in and mess with it. That would be a trimmer cap. So let's keep moving on. We got so much to do here. Diodes. Diodes are designed to allow current to flow in one direction without any problems, with very little resistance, but come to a wall if power tries to come back the opposite direction. It stops power from moving in the opposite direction. Allowing current to flow in one direction restricts flow from the opposite direction. Most of them are made out of silicone or germanium. You'll find diodes in almost every circuit. They're used a lot for power supplies, signal detectors. There's also another kind of diode that you're very aware of, such as, well, let's just start off with a basic. This would be your basic. It doesn't look very good, does it? This is your basic generic diode. Once again, this would be the positive side, anode, cathode, negative side. It allows power to go this way, but it doesn't allow power to come back. There's another kinds, like a Zener diode. That would be the schematic symbol for a Zener. Here's one that you're you've probably seen a lot throughout your life. You didn't know the symbol for it. It's this one. This is the symbol for an LED, a light emitting diode. Used in a ton of stuff. And that's the schematic symbol for a light emitting diode. There's also a photodiode, meaning it changes its value depending on how much light is coming in. Anyway, there's so many different types. There's so many. That's just the basics. Okay. Let's try a transistor. Okay, you'll have to excuse me. I've got more information on the board than wasn't there just a moment ago. I've been battling with the battery on this camera. Anyway, transistors. They're a semiconductor used as an amplifier or a switch. Here's your basic styles. Here's an NPN transistor schematic. Here's a PNP. If you notice inside, there's what looks like a miniature diode, allowing power to go in one way and not the other. There's another kind of transistor. First off, on these transistors, they have what's called a base, a collector, and emitter. And because these are reversed, they're different. Emitter, base, collector, emitter, base, collector. Over here you'll see field effect transistors and MOSFET transistors. These are made out of a different substance. They do basically the same thing, only they have other relative things that they can do. You may find a lot of FETs in shortwave radios in the front end of the receivers for the HF receive. And instead of a emitter base collector setup, they have what's called a drain, gate, and source. Drain, gate, and source. There's my dog thinking somebody's here. Anyway, these are N-channel transistors, field effect transistors, and these are P-channel transistors. Oh, she thinks somebody's here. I know nobody's here because it's later at night now. So, as far as the field effect transistors, also the voltage is determined through conductivity. But let's get into some other things before this battery dies on me here. Let's get into power sources. If you see this, not the swirl. If you see this, this would be considered a DC power supply of some kind, probably a battery. You might even see a number next to it, like 12 volt or 10 volt, 9 volt, 8 volt, 5.7, whatever. That's what a DC battery looks like. For AC, alternating current, it'll look like this. That's an AC power source. And once again, you may see a number next to it, like 120 or 120 AC. You might see that as well if you're in the United States. That's an AC power source. Opposite of power sources, of course, would be ground. There's a couple kinds of grounds. Here's your chassis ground. This would be an earth ground. Both do the same thing. They both produce 0 volts. They are ground. Chassis ground, of course, is for, if you were to have maybe a radio, an electric, a radio that has a metal chassis, that kind of thing. The chassis ground. The ground of the electric circuit board could be also considered earth ground to the chassis. They're both grounds. How about an inductor? An inductor stores electrical energy through magnetism when current is flowing through it. Here's what an inductor would look like. Here's what an inductor with an iron core would look like on a schematic. Here's a variable inductor iron core. Here's one you guys should know. What's that? That is, that's an antenna, a poorly executed one. Antenna. How about a switch? That would be a single pole, single throw switch. Make it a single pole, double throw. Now it's a double throw. There's so many different kinds of switches, but you can see what's going on here. That would be what a switch looks like on a schematic. How about a transformer? That's what a transformer would look like. That's what a transformer would look like with a secondary tap. This would be the primary. This would be the secondary. And this is considered the tap right here. Here's one for you that's very important. What are these and what's the difference? Well, there are various lines in schematics, all over the schematics. You'll find lines crossing lines all over the place. But you need to know that when a line just crosses a line, that doesn't mean that there's an electrical connection there. That just means that the electrical line's going somewhere to somewhere else in the circuit. This is not electrically connected. This one also showing no, it is not connected to this line. This one, however, shows and indicates that there is an electrical connection to these two lines in the circuit. That's the difference. No connect, no connect, connected. I think that's good for now. Let's get into the phonetic alphabet. Okay, phonetic alphabet. There are 26 words that are assigned to the Roman alphabet. These words are a standard. They are an international standard for a radio telephone spelling alphabet through NATO and ICAO. There might be some variables depending on countries, but it's very minimal. This is the standard through the world, and it's used for radio communications while gathering info over the air when there's a barrier such as a different language or poor radio conditions. Spelling out the message, you'll have a better chance of making a 100% copied message. And so every letter here has a word assigned to it. And everyone that's on the radio is supposed to know this phonetic alphabet. And I'll tell you what it's not first. It's not this. You can kind of see where I'm going with this here. I can keep going. Adam, Boy, Charles, David, Edward, Frank, George, Henrietta. Where that, I can keep going here. Nora, Ocean. Anyway. It's Ida, what would be Ida, John, King, Lincoln, Mary. Anyway, what I'm doing here, this phonetic alphabet is for law enforcement. Law enforcement has a different phonetic alphabet. And at least they do here in the United States. It's most likely everywhere else. But for amateur radio communications worldwide, for military, for aviation, I'm going to go through the whole thing here. I can spell it correctly. And kilo is a big one. It's not kilowatt. It's not kilowatt, it's kilo. Now these letters, these words have been selected through trial and error over the many years. Actually, radio phonetics started in about 1927. There's been about 7 different variations since then, and they finally came upon these specific letters to use right around what was it, 1965, and they've adapted to this in 1965 since. These are the words to use when spelling out something over the air. And whether it's your call sign, whether you're trying to relay some sort of information over a very great distance over the air, these are the letters you use. You don't use something silly like cheeseburger, gravy, limousine, just random words. If you do that to somebody that knows these words for the alphabet on the other side of the earth, trying to listen to you, they're going to scratch their head and go, "What in the world are you doing? I don't understand what you're doing." These are the phonetic words that all radio operators go by in amateur radio. So it's best for amateur radio operators to show some kind of courtesy to everyone else around the world using the same 26-word radio codes. Make it easier on them and you when relaying any information, whether it's your call, your location, whatever you're talking about at the moment, and you have to spell it out. You will hear people out on the air making up their own phonetic spelling for their call letters or what have you, just to be silly. But really, these are the ones that are needed. So, that's that. Well, I hope everyone enjoyed Elmer Time number 15. And I know I didn't go over how to read resistors because that would take a whole video all on its own. And as far as these phonetic words here, they were specifically selected so that they would not be mispronounced or sound like a different word when relayed over the air. So that's why they are what they are. Excuse my dog for barking. So anyway, thanks for stopping by. This is Alpha Delta 7 Lima November, and I'm Claire. See you later.